Alright guys, welcome to another channel episode. This is another episode in the series where I'm talking all about Tensorflow and getting my Tensorflow certification. So if that sounds interesting to you, please stay tuned and watch this whole video. If you're new here, I just wanted to mention that this is the channel where we talk all about how you don't need to be a CEO in order to have some impact on the world. And we're starting off by learning a little bit of data science in this channel, and right now we're getting our Tensorflow certification. So Tensorflow certification allows you to show people that you know what's going on with TensorFlow. It also allows you to have a structured plan in order to learn TensorFlow and come out of the other end knowing more than you knew before. So this is a great opportunity to learn more about TensorFlow and how I'm approaching it and how I'm trying to learn it in only 2 months. So if that sounds interesting, please stay tuned for this whole entire video. Alright, so now let's get started on where I've gotten so far and what I've done this week. So what I've done so far is I've been doing this course that is recommended by the TensorFlow certification people, and I've been doing it by deep learning on Coursera, and I'm on the last course. So there's four courses in the specialization, and I've done 3, and I've started now on the last one, the fourth one. The fourth one is on time series. So let me just get my log right now and I can show you guys my notes and also my calendar. Alright, so I've got my iPad with me here now, and let's go into getting TensorFlow certified. So this is my Notion page, and here I've been keeping track of my logs. Now if I scroll all the way down, you can see my logs. So we started on February 7th, and it is now March, I think it's March 31st or April 1st when I'm filming this. And as you can see, we're approaching the end where I'm going to take my TensorFlow certification. Now I still got a week left, and I still got a little bit more of this course left as well. So as you can see here, I did on March 28th, I did week 1 of the TensorFlow course. This was a couple days ago. And on March 29th, I started on week 2 of the TensorFlow course. Now, unfortunately, I didn't finish that, so I won't be going over that in this video, but what I will go over is my notes for week 1, and week 1 was actually very jam-packed. It had a bunch of information that is new to me. I've done some time series work before, but I think the course did a very good job in kind of reminded me the basics and how simple models work better than more complicated ones. So I've had a lot of fun with this, and I can't wait to show you my notes because there is a lot. So let's go over to that page and I'll show you my notes and I'll talk about it. So here we go, my notes. I would like to mention that some people have been mentioning that I haven't been putting the links down below of my notes, and I've been meaning to do that. I've just been forgetting. So thanks for reminding me. I will definitely start putting my notes and all of this information down below for you guys to click through and read. It's a link to my website, and in my website you guys will see kind of a bunch of different pages that you can choose, and one of the pages will be this one, the Getting TensorFlow Certified. So once you click on that, you'll be able to see all my notes and see exactly what you're seeing on your screen right now. And in order, you can copy it, you can duplicate it, you can do whatever you want with it. It's just some notes I'm taking. And so I hope you enjoy working on that yourself. So here we go. We have the time series here. Before that, I have all the different weeks, but here I have the time series one. I'm going to click on that, and we're going to go talk about that. Now, there's a lot of information. I haven't memorized it all yet, but I understand it all, so I can't wait to share it with you guys, my thoughts, what was difficult, what was easy, and what I need to continue learning. I have some notes on all of that right here. So let's get started. So here we have about an intro basically, and we started off by learning what a time series is. You have univariate and multivariate. Basically, how much information, how much data points do you have per time period? right? So if every minute you have one, the temperature, that's only one data point, and so that's a univariate. But if you had something like the weather, the temperature and the rain, right, more about the weather for each minute, then that would be a multivariate time series. So we learned about that. Then we learned about, in time series, all the kind of the things you have to worry about, and there's like 4, right? You have the autocorrelation, you have the trend, the seasonality, and you have the noise. Now noise is actually kind of annoying. We can work with noise, but some noise is so loud that it doesn't actually let us do anything with the data, and it's basically just no, right? Nothing we can do with that. Seasonality is what it kind of sounds like. It changes through the seasons, but not only the seasons, but there's kind of like this pattern that occurs. It can be daily, weekly, hourly, it could be yearly, and we call that seasonality. And then we have trend. Trend is kind of a simpler version of seasonality. It's kind of like, if we're going upwards, it's an upward trend. If we're going downwards, it's a downward trend. It's very easy to understand. Now sometimes we can get non-stationary. We'll go over that, but you can have stationary and non-stationary. Here, I'll just show you guys. So in non-stationary time series, you have a trend that starts one way and then it breaks and goes another way. And so that's called a non-stationary. As you can see here in this picture, you have a trend that's going upwards with a lot of seasonality, you can see. And then it breaks. Some event happens, some scandal, some technology shift, and it just starts changing. So that would be a non-stationary. Stationary is one that follows a trend and never stops. And so what are we trying to do with the time series? Well, with time series, what we're basically trying to do is we're trying to predict the future, right? We're trying to predict or forecast what's going to happen in the future for data we don't have, which is hard. It's hard, but we have some tools to do that, and I'm going to show you the very easy, simplest tools. Now, these tools are not so machine learning based. These are more just statistical tools. But like I mentioned today, I've always done the machine learning way, and so learning about just the basic statistical way is very beneficial. So let's go on to that. So here we have different ways to actually do the testing for the training validation split. Because of the way this data works, you can't just partition it in any way you want, because it's time based and it has to be in a row. You can't just get 1 minute, put it there, and then the second minute and put it over here. So by that I mean you can't just get 5 minutes of data and then put it into your training, and then the next 5 minutes put it in your validation, and then get another 5 minutes and put it in your testing. Because the way it works is that the time series, there's trends, there's seasonalities, and they're grouped together, and so you actually have to be smart about how you split your data. Now, this is something that actually in the beginning I always wondered, what are the different ways to do this? I knew the first way, which is fixed partitioning, where you kind of grab a chunk and then the next chunk, and then you leave the next chunk. So like you get the training period chunk, and you make sure you get a whole season at least in that. And then you get the validation period, and then you get another smaller chunk, and then for the test period, it's like the last chunk. And I knew that you always want the test period to be the last part, because what you're trying to do is you're trying to predict the future, and the best prediction of the future is kind of what's happened most recently in the past. And so you always want to have it in this way. You can't just do the test period in the front, and then the validation, and then the training in your most recent data. That wouldn't be the most beneficial thing. Sometimes maybe if you're trying to actually predict the past, that might be smarter, but in this case we're trying to predict the future, and so fixed partition is the way I knew. But there's other ways. There's fixed partitioning, where actually your test period is actually in the future. It's data that hasn't happened yet, and you use your validation as your your kind of like the latest data you have. And the reason you would want to do this is kind of like what I mentioned before. The most important data that you have is the most recent data. It's the data that's most likely going to predict what's going to happen in the future. And so you kind of want to train with that data. Losing out that data to your testing kind of sucks. So that's another way. And a newer way that I didn't know about is roll forward partitioning, in which kind of you get the training period and you keep elongating it while you get the validation period, and you keep shortening it in order to kind of do kind of a cross validation kind of situation, right? That's kind of one of the ways, right, to think about it. And then we learned about mean squared error versus, I didn't finish that, but it's the mean absolute error. So mean squared error versus mean absolute. Mean absolute error. Bam. Fix that. So what are the differences? So we know that the mean squared error, it's in the name. You get the errors and you square them. And then the mean absolute error, you get the errors and you do the absolute value. Now the square, what you're trying to do there is actually get rid of the sign, and the absolute value gets rid of the sign as well. So you would think that they're like the same thing. And so in the mean squared error, when you square the terms to get rid of the sign, you're sometimes penalizing a lot for these values that are really big. Sorry, you actually, you are penalizing a lot. But on the other side, your MAE, right, your mean absolute error, because it has the absolute value, you're not getting those very large numbers, your very large errors being kind of blown up exponentially. And so that's another way to focus on your errors, is when you don't really want to penalize so much the ones that are incorrect, like the mean squared error does, use the mean absolute error. Again, in both of these, you're trying to get rid of the errors that are negative because they would cancel out with the errors that are positive. But these are different ways to think about it, because when you're squaring an error, if your error is really large, like 10, it's going to blow it up. Versus if it's like 1, it's not going to blow it up as much. So it's penalizing larger errors. But the absolute value, because you're not, multiplying it by anything, you're not penalizing the errors by so much. And so that is just the differences of the errors that you can use to kind of judge how your model is doing. And then later on, we start just talking about what is one, way to do this. And this is, again, like I mentioned, this isn't very machine learning based. This is more statistical learning based, which is fine, which is awesome. So in this case, we use something called a moving average, which I'm sure most of us have heard already. You get a period of time and you move that period of time along, and you calculate kind of like what the average is, and then you set it as that point in the beginning. And then you move it another period of time, you get the average, and then you put it as that point, and then you kind of have a moving average. And so in this section, we have a moving average of 30 days, and we keep moving it along, and you can see that it kind of predicted pretty well, actually. Not that well. It's kind of over predicting in the beginning, and then it kind of like goes better. It's okay. But actually, very simply, we can do something called differencing that makes everything much, much easier for us. So, what we do here is the faults of the moving average, we fix it by first differencing. So that gets rid of any of the trend and seasonality. So what we do is that we get the time series and we subtract it by a point that was earlier in the time series. And so this gives us kind of something that looks very noisy to us, but the computer can still do a moving average on that. and get a very good prediction. Now the problem is that you can't then predict anything on this because it is a difference. It is the series minus the series at a certain point. So what you then just do is that to these moving average predictions, you see the orange line there in the blue, you just add back that point that you subtracted earlier in order to get your prediction, and it works very well actually. And in fact, you could even do something even better than that. You can actually, instead of adding back that point that we had first subtracted the whole series by to get rid of the seasonality and the trend, what we can actually do as well is we can do a moving average before and after, right? So instead of adding back the point, right, that has all the trend and the seasonality into the differenced model that doesn't, we actually just add back the moving average point instead of the original point. And so what this ends up giving us is a lot of smoothing, but incredibly good predictions, like very good, like why, like it's just such a simple thing to do, you know. It's literally like a moving average and a subtractions, but when you put them together, you have a model that can get very close or even sometimes better than your best machine learning model that you've trained over a long period of time. So I really enjoyed learning this. It's something that I didn't know. Very easy method, and you know, it's so fast you can try it before any model you do for machine learning. And then the last thing we learned is about trailing and centered windows. This is just on how you move that, you know, that window, the moving average window. And honestly, I was a little confused in this part, so this is a part that I'm gonna want to review. So I'm gonna want to go later on. I have the note here that this is something I want to review, so I'm going over my notes. I know, hey, this is actually something that I was confused on. Why don't I just look it up right now and add in the notes, and then, you know, smarter every day kind of situation. So that is kind of, wow. I mean, that was just 1 week. It was a lot. I usually get, you know, 2 weeks done in its time period, but I only got one, and then I started week 2, so this was definitely a lot of information that I really wanted to get right. Awesome. So that was it for this week. This is what I learned. I learned all about time series and introduction, and a little bit of some statistical learning modeling, right? And if you enjoyed, just let me know. The sound is better. If you guys want links to certain things, links to the Coursera course, just let me know. You guys want videos on any other things I do, let me know about that as well. If not, that's kind of it for today. Leave me a thumbs up, and I'll see you in the next video, where hopefully I can talk about week 2, week 3, week 4, and later on the 7th, we are going to be taking the Tensorflow course. That will be our 2-month point. That means I'll be making these videos weekly for 2 months, and it also means that I would be finished with getting my Tensorflow certification, and the next video I would make, for not next week but the week after that, will be whether or not I got the Tensorflow certification, my thoughts, what I would do, what I would change, and things like that. So if that, you know, sounds interesting, just subscribe, and I'll make a video on that in the incoming weeks. And yeah, thanks for joining in. Remember, try to be smarter every day, and I'll see you next time. Peace.